What if we detonated a nuclear bomb at the deepest point on Earth? Would the oceans boil? Would a mega tsunami rise from the depths and crush coastlines? Could it trigger earthquakes or even crack the planet open? Let's dive into the darkest, most dangerous hole on our planet and find out. The Mariana Trench, located in the western Pacific Ocean, is a crescent-shaped scar in Earth's crust. It stretches over 2,500 kilometers long and plunges almost 11 kilometers deep. That's deeper than Mount Everest is tall. At its lowest point, the Challenger Deep, the pressure is over 1,100 times that of sea level. That's like having 50 jumbo jets stacked on your chest. The temperature? Near freezing. Sunlight? Non-existent. It's a pitch-black world, hostile and silent. And yet, despite all odds, life survives down there. Bioluminescent creatures float through the darkness. Bacteria feed off chemicals in the rock. It's one of the least explored places on Earth, and perhaps the most mysterious. Now imagine we drop a nuclear bomb into this abyss. Not just any bomb, but something massive. Let's say the Tsar Bomba, the largest nuclear weapon ever detonated. It had a yield of 50 megatons, more than 3,000 times the bomb dropped on Hiroshima. But what would actually happen down there? Let's start with the basics. When a nuclear bomb explodes, it releases an immense amount of energy in the form of heat, light, radiation, and a powerful shockwave. In the air, this creates a blinding flash and a fireball that can vaporize cities. In water, it's different. Water is denser than air, much denser. This means the explosion's energy is absorbed and dispersed more quickly. Instead of a mushroom cloud, we get a giant superheated gas bubble, expanding violently before collapsing under the crushing pressure. At the surface, underwater detonations can lift ships, tear apart submarines, and generate tsunamis. In fact, in 1946, the U.S. conducted Operation Crossroads, detonating nuclear bombs underwater at Bikini Atoll. The explosions launched massive plumes of water hundreds of meters into the sky. They were terrifying, even though they happened in relatively shallow water. But the Mariana Trench is no shallow pool. It's nearly 11,000 meters deep. At that depth, the pressure is so extreme that even the shockwave of a nuclear bomb would be restrained. Instead of a dramatic eruption, you'd get a massive underwater bubble of steam and radioactive gas, one that would rise a little before being crushed by the ocean above. The energy would be absorbed, muffled, and swallowed by the sea. So no, it wouldn't split the ocean open. It wouldn't destroy continents or trigger the apocalypse. But that doesn't mean it's harmless. Far from it. The real danger isn't the boom, it's the fallout. When a bomb detonates underwater, radioactive particles mix with the surrounding water. These radioactive elements don't just disappear, they travel. Ocean currents would begin to move the radiation through the deep sea conveyor belts, the global circulation system of the ocean. Slowly but surely, radioactive material could rise toward the surface and enter the marine food chain. Tiny plankton absorb it. Small fish eat the plankton. Bigger fish eat them. Eventually, humans eat the fish. And the radiation reaches us. And here's the scary part. Some of those radioactive isotopes can remain dangerous for thousands of years. Cesium-137, for example, has a half-life of 30 years. That means the radiation would linger in the environment, traveling across the globe, silently poisoning life. And what about a tsunami? Could a bomb trigger a giant wave? Unlikely, especially at that depth. To create a tsunami, you need to displace a large amount of water very quickly, like when an earthquake shifts the seafloor. But a bomb at the bottom of the trench would have its energy trapped. The water above it is too heavy, too powerful. The shockwave would be swallowed before it could move enough water to generate a wave. Even if a small wave formed, it would weaken dramatically before reaching land. No massive wall of water. No apocalyptic flooding. Could the explosion trigger an earthquake? Not really. Tectonic plates hold energy equivalent to thousands of nuclear bombs. Even a 50 megaton blast is tiny compared to the energy released by plate movement. And in the Mariana Trench, it's not located directly on a fault line that would shift from such a blast. So no nuclear-triggered megaquake. So far, it sounds like a deep-sea bomb is disappointingly dull. No surface-level chaos, no tsunamis, no earthquakes. But here's what's terrifying. We wouldn't see it. We wouldn't even know for months, maybe years. And yet the ocean would silently carry death. Invisible, undetectable, a disaster in slow motion. And that's the lesson here. Power doesn't always explode in your face. Sometimes it leaks, silently, slowly, dangerously. The ocean would absorb the bomb, but not the consequences. And for thousands of years, humanity could suffer the effects of a decision made in darkness. So, what's the takeaway? Nuclear weapons are designed to destroy. And even in places where they can't shake the earth, they can still poison it. Even in silence, they scream. So, the next time we talk about power, remember, just because you can drop it into the ocean doesn't mean it disappears. Thanks for watching Adam's Mind. If this video made you think, subscribe.